Okay, in this Desmos activity, you have to write the equation for the function and state the key features. Now, you won't have the regeneration button, but all your equations will be randomly generated. And when you get your screen will not look like your neighbor screen. So let me go ahead and pick this one and then say, okay, there's the y-intercept, there's the x-intercept. What is the function of this line? Well, I know that the y-intercept is 0, comma 2, so I'm going to go ahead and put that in. And the domain is, wait, hold on. The domain, I'm going to just copy this, is negative infinity to positive infinity. And the range is negative infinity to positive infinity. The slope, you can see here that I rise to, run 1. So that's rise 2 over 1. That's basically 2. And the x-intercept, the y-intercept is 0, comma 2. So the initial value is 2. The equation of the line is, and you can say 2 over 1x plus 2, but you don't have to write the slope as a fraction if it in fact reduces to an integer or reduces to a smaller fraction. So it's going to be 2. And the rise 2 over 1 is the, and this is a positive increasing slope. And why is this not, oh, positive 2. The initial value is positive 2. So you could just write it as 2x plus 2. Let me do another one. So I'm going to erase my answers to this one and everything except for the domain and the range. And I'm going to regenerate another problem. Okay, and here's another decreasing one. Here we go. The y-intercept is 0, comma negative 4, close parenthesis. That means the initial value is negative 4. And the slope clearly is, and you can see here, there's the y-intercept, there's the x-intercept, and or the x-intercept and the y-intercept, that it goes down 4, and it runs 8. You can see that. So it's down, it's a negative 4, and runs 8. That's basically a half. So you can write it as 1 over 2 or 4 over 8, but you want to do reduce the fraction. So that's going to be a negative 1 over 2 x minus 4 is the initial value. And this is a decreasing function and negative slope. Okay, so that's 2 examples of what you're in for in the next couple of slides. Okay, so now here is an example of an exponential function that hasn't really been transformed. I'm going to pick one that's been transformed. Okay, so here's one that's been transformed. It's been shifted up 3. That means all the points have been shifted up 3. Okay, now, so in this situation, these points aren't the initial pre-transformed points. For example, this point 0, comma 10 was actually 0, comma 7, and then it shifted up to 10. So let's keep that in mind. Let me just make a note right here. 0, comma 7. And this point here was not 1, comma 24. It was 1, comma 21. So it was 1, comma 21 before it got shifted up 3. So the ratio is 21 over 7. And clearly it tripled, right? It was a 7 and then it became a 21. So the multiplier is 3, right? And the pre-translation initial value would have been 0, comma, or rather just the value would have been 7, right? Because this before it was 10, it was 7 and it got shifted up 3. K value is 3 because that's the value of the asymptote. The asymptote is y equals to 3, right? So now I have all the pertinent information to write the equation. A is 7, the pre-translation initial value. And then the multiplier is 3, and that's 21. Notice how that gives you 21. You can see it right there. It just came out on the screen. And that's 21. And then you shift it up 3 by adding 3. And notice how the screen here, let me do that and put like 0, right? You see the curve there, and then you add the 3 and it shifts it up, right? And obviously the y-intercept is not the initial value because it's After you translate it, it's a different number. There it is. And the domain and range. What is the domain and range? Well, the domain and range is, the domain is negative infinity to positive infinity. The range is the lowest possible value, which is in this case y equals to 3, and then it goes up to positive infinity. And this is an exponential increasing, and b is greater than 1, and it is a growth factor. Okay, so there is how you would do this particular problem, right? So let me erase all the answers. All the answers. Let me regenerate another one. All right, let me generate one that I like. You don't get a choice. You get whatever you get, right? So you're going to get a curve, and you don't really get to regenerate it. You're going to stuck with whatever you get. Here's another example that is shifted down. So if it is shifted down, before I shift down, that 0, 15 is 0, 16, right? Because then it got shifted down. And that 1, 1, before it got shifted down was 1, 2. So here we have the initial values. What's the b? Well, the b would be 2 divided by 16. The second point, f of 1 divided by f of 2, that's going to be 1/8, right? That reduces to 1/8. Notice it's 0.125, and 1/8 would be the same thing. So, and you could see that it's 1/8 because it's like, well, 16 divided by 2 is 8, so that's 1/8, and it is a decay. So it is a decay factor, right? And that's what the decay rate would be, or the ratio, not the decay rate. The ratio would be 1/8, right? Okay, so let me erase these points here, and the domain is 0, negative infinity to positive infinity. The range would be the lowest possible point, in this case -1, from -1 all the way up. That's the range. And the pre-translation, so in other words, before I shift it down, a was 16, and k is the -1. That means the asymptote is y equals to -1. That's the little red line there. So now the intercept is the current intercept, 0, 15, and then the equation of the line. Well, you have all the components of the line. So it's 16, 1/8 raised to the power of x, and then you shift it down, and you could see it there. You could see it there in red. Now I'm going to shift it down by subtracting 1, and it lines up perfectly with the green line. There it is. So I get all the points there. Now, my values here on my example here are random. So I could do this whole activity, and they may not look like yours. So I'm going to go ahead and do a few more.